Hi guys, so today we're going to talk about Unit 3 transformations. So we're going to start off with what is a transformation. So a transformation is it's an operation that you do that maps the original figure, which is what we call the pre-image, onto a new figure, which is called the image. And so most of the time it's going to be denoted by just your regular letter or regular point, and to the new one, which is called the it has a little apostrophe, which is what we call prime, right? So that is read as B prime. This one's just B. And here's what we have, the pre-image, and this one is what we call the image. Okay. What we need to remember is what a transformation does is it takes your original image, which is called the pre-image, and it creates your new image, right? So here, this arrow essentially represents the transformation that it does. Okay, and there's different types of transformations, but we're gonna focus on two, or two types, which is called rigid motion, and the other one's called non-rigid motion. We'll get to that in a bit. But for rigid motion, know that for any rigid motion transformations, it preserves size and shape. And so what that means is that, think of it as kind of like copying and pasting on Microsoft Word, and you're trying to just changing the location of where it goes, right? So you're not changing the size, you're just kind of changing the placement of it, right? So you're either going to move it up, down, left, right, you're going to rotate it, you're going to reflect it, etc. Okay, so those are the three main types of rigid motion transformations that we're going to talk about, which is translations, reflections, and rotations. Okay. So let's talk about what a translation is. A translation, think of it kind of like a slide or a shift of a figure, and you can move it up, down, left, right. So up, down is what we call vertically, left, right is what we call horizontally. There's the notation that we use for translations is what we call coordinate notation. And you can think of this, or they're always going to start with this, which is kind of like your original, right? And then here's telling you what you're going to do to produce your new image. So essentially this right here is your translation or the transformation, right? And that's going to produce your new image, which you call prime. And so even though it has a plus right there, it can essentially be negative. And so the way we determine whether it's plus or minus or positive or negative is depending on your shift. So if you go to the left, you're going to see minus. If you go to the right, you're going to see plus. And vertically, same thing. So if you go down, you're going to see minus. If you go up, you're going to see plus. So let's take a look at our first example here on translations. So here we're given a rectangle with vertices Q, R, S, and T, and I already plotted them for us. And they're asking you, after you apply this translation here, what are going to be the new coordinates, right? So first of all, this translation is interpreted as you're going to move 5 units to the right. And this second part is telling you you're going to move 7 units in the up direction, right? And so what I want to do is, so we're going to apply those same things here to every single vertex, starting with Q. So 5 units to the right. So 1, 2, 3, 4, 5. 7 units up. 1, 2, 3, 4, 5, 6, 7. Puts me at Q prime. And Q prime is at -1 comma 6. And we're going to repeat the same process, but this time with R. So 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5, 6, 7 units up. Puts me up here. We'll label that R prime. And that is at 2, comma 8. And repeat the same with S. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Call that S prime. And S prime is going to be at 6, comma 2. And lastly, we have T prime. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. and label that t prime. And t prime is at 3, 0. And so what I want you to realize is that if I were to find the slope and the distance for each one of these segments, they're all going to be the same. They're going to be congruent. Okay. But that's not what I want you to realize. What I want you to realize is that if you notice, this right here is telling you exactly what to do to each x and each y, right? And so essentially, we really didn't have to count on the graph every single point. We could have just done this algebraically. So here's what I mean. So this x plus 5 is telling you for every x value, you add 5 units to it. So if I were to add 5, that puts me at -1. If I were to add 7, that puts me at +6. And we repeat the same process. If I add 5 to -3, that puts me at +2. If I add 7 to 1, that puts me at 8. And so on and so forth. If I add 5 to 1, it puts me at 6. Add 7 to -5 puts me at 2, so on and forth. Add 5 to -2 puts me at 3. Add 7 to -7 puts me at 0. And so essentially, we could do this without the graph. We can do this just knowing this and the original points, right? And so that's what I want to do for this problem right here. So I'm going to write out the original, right, the pre-image vertices, or the points of C, D, and E. And the transformation that I'm doing here, that's going to produce my C prime, D prime, and E prime, is this right here. So this is saying we're going to move left 3 units. And this part is saying you're going to move up 8 units, right? And so again, we can apply this to each one of these points, right? So if I subtract 3 from 2, that puts me at -1. If I add 8 to -1, that puts me at 7. And we repeat the same process. If I subtract 3 from 7, that puts me at 4. Add 8 to -4, that puts me at +4. Subtract 3 from 4, that puts me at 1. Add 8 to -2, that puts, -6, that puts me at +2. And so I just want to check 2 points just to make sure that I'm on the right track, right? So let's start with E. So if I move 3 units left, so 1, 2, 3, 8 units up, so 1, 2, 3, 4, 5, 6, 7, 8, it puts me at 1, 2, which checks out exactly what I calculator, right? And same with D. So 3 units left, so 1, 2, 3. 8 units up puts me at 1, 2, 3, 4, 5, 6, 7, 8. Puts me at 4, 4, right? And so for C, would have been at -1, 7. And that's C prime. And so once again, if I were to measure it, if I can somehow remove this, paste it there, that would be exactly the same thing. So what I want you guys to do now is in the chat, okay, in the chat, I want you to type, or I want you to tell me what are the new coordinates. So in the chat, I want you to type this part right here, okay, and you fill in the blanks. Once you're done, resume the video so that you get the right answer. So go ahead and pause the video now and put the answers in the chat. Alright, so I hope you actually paused the video. And so let's quickly go over in case you need it. If not, fast forward and see the answer. But if I subtract 3, subtract 4, that puts me at -3, 3. If I subtract 3, subtract 4, that puts me at 4, -1. And then finally, subtract 3, subtract 4, that puts me at -2, 0. You got it? Rock star. All right, so now we're going to talk about reflections, okay? So think of the reflection kind of like a mirror, right? So you see the exact same thing on the mirror, only that it's flipped, right? So your right side, if you pick up your hand on the right on the mirror, the mirror, that's going to be its mirror's left hand, right? And so that's why we think of it kind of like as a flip, right? And in this case, we flip over a certain line or a specific line, and they will always specify a line, or they'll ask you to find which line is being reflected over. That line that is being reflected over is what we call line of reflection. Sometimes you might see it abbreviated as LOR, okay, line of reflection. And the way we determine what a line of reflection is, or where the line of reflection is, it's always going to be exactly in the middle, right? So essentially, if you want to find the line of reflection, or where it's located at, you want to find the midpoint between the two vertices, right? And not just any vertices; they're going to be the vertices that goes from its pre-image to the image. And so what we have here is essentially, if we have a graph, we can count, right? Even if we don't have a graph, we can still count. And so what we want to get to is that the line of reflection is going to be exactly in the middle between the image and the pre-image. And we know it's in the middle because we simply count the distance of the two vertices, right? So here's what I mean. So C is 1 unit away from the line of reflection. C prime is also 1 unit, right? A is 1, 2, 3, 4 units from line of reflection. A prime is 1, 2, 3, 4, right? So essentially, if I wanted to reflect it, I simply count. So 1, 2, 3, that's 3 units over. So starting from the line of reflection, if I were to count 3 units over, that's where I would put my B prime, right? Or that's where I put the image vertex. And so there's different types or common lines of reflections. And I went ahead and highlighted them for you, right? So the most commons are the y-axis, or sometimes it's labeled as x equals 0, the x-axis, or y equals 0. Then we also have the line y equals x and y equals negative x. And then these last time, vertical lines, right? That is not the axis. So for example, a vertical line can be here, and I can say this is my line of reflection, right? And so the way we determine the equation for this line of reflection is, if you notice, it's x equals and then the number. That number represents the x value that it goes to. So in this case, 1, 2, 3, this equation would be x equals negative 3, right? Or if it was over here, we simply figure out what x value is it going through, and that's going to be the equation for it. So 1, 2, 3, 4, 5, 6. So x equals 6, right? And the same goes for horizontal lines, not on the axis, right? So if my horizontal line is here, well, let me use a different color. If my horizontal line is here, all I got to do is, what y value is it going through? And that's the equation for it. So 1, 2, 3, 4. So y equals 4. If it was down here, right, figure out what y value is it going through, and that would be the equation for it. So 1, 2, 3, 4, 5. So negative 5. Okay, so that's what it means by these numbers here. Okay, so these are all possible types of line of reflection. So let's get a little deeper into them, right? So for line of reflection over the x-axis, okay, so I want to do something. So remember, they have to be same distance, right? So we'll have A, B, and C. So the location of A is 1, 2, 3, 4. So it's at negative 4, comma, 0. No, I'm line 2, sorry. And then the location of B is at 1, 2, 3, 4, comma, 2, 3, 4, 5, 6, 7. C is at 5, comma, 1. And what I want to do is I want to create my new vertices, right? So after I reflect it over the x-axis, remember they have to be in the same distance away from line of reflection, right? So that's 1 unit, so that's 1 unit down, that's C prime. C prime. And I want to ask you, did the x value change or the y value change? Now in this case, the x values did not change, so it's still at 5. But the the y value is now below the x-axis, which now is at negative 1. Okay. See if we can find a pattern here. Let's talk about B. So B, once again, it's not going to change as far as left and right, but up and down, it was 7 units from the line of reflection, right? So that means it should be 7 units down. So 1, 2, 3, 4, 5, 6, 7. And that's B prime. And so the coordinates are 4, negative 7. And same for A prime. A prime, we got 1, 2 units. So 1, 2 units will put me there. A prime. Now again, if I were to find slope, distance, etc., you will see that they're exactly the same. The new coordinates of A is negative 4, negative 2. So what I want you to realize, or I want you to see, is what changed, right? So we started with the original xy. How did it change? First of all, we're not adding or subtracting, right? You guys said the x values are not changing, right? So since the x values are not changing, it's still x, the original x. The y, however, is the same number, but it's just a different symbol. And so if it's the same number, then we put y, and if it's a different symbol, then we put a negative, right? And so this right here is what we call the rule, right? So that's a rule whenever we reflect over the x-axis. So what this rule does for us is that any time that we know we're going to reflect over the x-axis, instead of counting, we can just simply apply this, right? And that helps us because let's just say I want to reflect the point 5, 10, right? If I want to reflect it over the x-axis, I don't need to count, I don't need to do anything. I can take my rule, which states it's going to be the same x and the opposite y, and I'm done, right? So that's why these rules are important to us. And so the same way we figured the rule for over the x-axis, can we find the same rule or a similar rule for reflecting over the y-axis? So let's figure it out. So flipping it, let me back up. So over the x-axis, we rotated here, or we reflected here, right? Over the y-axis means we're going to reflect over this line, right? So everything here is going to go over there. Everything here came down there, right? So let's see if we can figure out what it is. So the P is going to go from here, 1 unit over, so it's going to go there. That's still P prime. Q is 2 units over, so that's still there, Q prime. R, if you notice, just down at the corner, same height, same location. The only difference is now it's flipped on this side. And S is 1 unit off, so that's S prime. And so essentially, really, if I can fold my screen, right? If I can fold my screen and fold it along this edge right here, right? This rectangle would match up over here, right? So all of these points would match up on these points over here. And once again, we should notice that the y value up and down, it did not change, right? Because these are still at the same height, right? Same height, same height, same height. What did change, however, was the x value, right? So here it was at positive 2, over here it became negative 2. For P, it was at positive 1, became negative 1. For S, it was at positive 7, over here become negative 7. For R, because it was at 8, became negative 8, right? So when we reflect over the over the y, we start with our original xy, and how it changes. We said the y value is not changing at all, so that's staying the same. But the x value is still the same number, the only difference is flipped, right? So this is the rule for reflecting over the y-axis. So now let's take a look at our reflecting over the x, or the line y equals x and y equals negative x. So in similar fashion, now this is a little bit trickier. Officially, it talks about drawing perpendicular lines to each one, right? Perpendicular lines just states that the opposites need to be reciprocal slopes, right? So how you get from one point to the other, you just do the opposite here. So here's what I mean. So if I start here, to get to Z, I go 1 unit up, 1 unit left, right? So if I were to flip that, I have to go down 1, right 1. That puts me at Z, or Z prime. And so let's write the coordinates of that. So z was at -1, comma, -1. Z prime went to +1, comma, +1. I'm sorry. Z is at -1, comma, 1. Z prime is at 1, comma, -1. Okay. And we're going to use different color. So starting here, right? So x, I have to go 1, 2 left, 1 up. That means I gotta go down 2, 1 right. And that puts me at x prime. So the original x was at -1, 2, 3, 4, 5, comma, -2. X prime is now at -2, comma, 1, 2, 3, 4, -5. And then lastly, we have y. So to get to y, I have to go 1, 2, 3, 4, 5, 6 units up, 1 left. So that means I go 6 units to the right. 1, 2, 3, 4, 5, 6, 1 down. Puts me at y prime. And so once again, if I were to find the slope and distance of each one, I would see that they're exactly the same. So y was at -1, 2, 3, -3, comma, 4. Y prime is now at 1, 2, 3, 4, comma, -3. And so with that information, see if we can figure out what the rule is. So this is the original xy. What happened? If you notice that -x became the original x became the y, right? It didn't switch signs, it's still negative. It just switched location. Same with this +5. -5. Sorry, that should have been a -5. Same with this -5. That -5 became here. Same with this -3. That -3 became the y, right? So the x and the y's are switching position. And if you notice, that's the same for the y. So the original y became the new x, original y, new x, original y, new x. So essentially, they're just switching position. So whenever reflect over line y equals x, we get the rule y comma x. Okay. And in similar fashion, we can repeat the same process here. This should be y equals -x. We repeat the same process and we get the rule whenever we reflect over the line y equals -x, we get the rule x comma y goes over to, so everything still changes, right? The only difference is now we actually switch the symbol. Okay. All right, so last one. So for reflecting over the vertical line, remember they're the same distance, right? Same location. And so what I recommend is counting. But remember, whenever reflect over vertical lines, x changes. Whenever we reflect over horizontal lines or y equals lines, then the y changes. What happens to the x? Well, the x stays the same, right? Because over the over the vertical line, we're reflecting this way. Over the horizontal line, we're reflecting this way, right? So the as far as left, right, up, down, it only changes when you're switching in the opposite direction, right? So here our prime would be there, right? For S, we simply count. So that's 1, 2, 3, 4, 5, 6 units. So 1, 2, 3, 4, 5, 6 unit puts us there at S prime. For U, it's 2 units over. So 2 units over will put us there. For T, it's 7 units. So that puts us here, T prime. Okay. And so once again, if I were to find the slope, find the distance of each one of these, we would get that they're exactly the same, right? So the coordinates, as far as the x values, it's the same distance from here. So here's what I mean. So R, and we're just gonna focus on the x value, right? So we understand that the y is still the same. So y is at 0, 1, 2, 3. R prime, okay, so we already know y staying the same, right? So it's going to be kind of the same for all of them. But the x value is the one that's changing, right? So what I recommend is see the difference and go in that direction, right? So if you think about it, 0 is to the left of, 0 is to the right of 1, right? So and essentially, if we have a number line, 0's here, -1's there, we're going in that direction, right? So that's 1 unit over. So 1 more unit over puts us at -2. And indeed, that is at -2, right? So the same process for U and S and T, right? U is at 1, -2. So for the y value, we still know it's going to be a -2, but for the x, so once again, so here's what I'm doing in my head. So 1 is here, right? 0, not 0. Line of reflection is at -1. From 1 to -1, that's 2 units. So 2 units more in that direction puts me at -3. And if we look at U prime, that's 1, 2, 3. That is indeed at -3. And we repeat the same process for T and S. So T is at 1, 2, 3, 4, 5, 6, -1. I know T prime is going to be at the same y value, so still -1. For the x value, however, so here again, with picture of number line, 6 is there, my line of reflection, ROL. So from 6 to -1, that was 7 units. So 7 units more over that way puts me at -8. And if we count to find the coordinate of T, it's 1, 2, 3, 4, 5, 6, 7, 8. Right? And so that's what I mean by counting. Really, you got to figure out what's changing as far as the x or the y. So S is at 5, 4. S prime we know is going to be at the same y value. The x, however, so one more time, picture my number line. Here's 5, here is -1, or my line of reflection. So from here to here, that was 6 units. So 6 more units in that direction puts me at -7. If we count, that is indeed at -7, right? And so the same process we do for whenever we're reflecting over the line or horizontal line. The only difference is now that y is the one that's changing, not x, right? So we're going to apply the same process. So here my line of reflection is 2. And if we're going to talk about the first point, E, right? So E is at 1, right? So and we're going that way because 1 is above. 1 is below 2. So to here, get to my line of reflection, LOR, line of reflection, that's 1 unit. So 1 more unit puts me at 3. Oh, you can't see that. So here puts me at 3, right? And if you can see it, we can just simply count 1, 2, 3. That is at 3. Same with F, right? So F is at 1, 2, 3 at -3. And so to get from -3 to 2, we had to add 5. So if I add 5 more, that puts me at 7. And so the location of my f prime would be essentially at 7, comma, and then whatever the x value it's at, right? So let's find out if that's true. So remember, they have to be the same distance. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And if we count to figure out what coordinate that is starting from here, that's 1, 2, 3, 4, 5, 6, 7, right? And we can repeat the same process for every single one if we don't have a graph, right? If we have a graph, we simply count. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. C prime. And so once again, if I wanted to find the slope, the distance of each one, I would see that they are all congruent. Okay. So summary. We talked about different transformation. We talked about translations. In translations, we have what we call coordinate notation, where h, y plus k, h, if we go to the left, it's minus. If we go to the right, it's plus. For k, if we go down, it's minus. If we go up, it's plus. And then we also talked about reflections. And there's different type of reflection. So we go across the x-axis. The rule was that you take your original xy. Now think about it. The x-axis, it's you're going like up and down, right? And so the x does not change, the y does. When you go across the y-axis, it flips, right? The y is not changing, the x is. When we go over y equals x, we have the two values, or the x and y, they switch locations. When we go over the line y equals -x, they still switch. The only difference is we switch the symbol as well, right? And then we have over horizontal. So horizontal means is going to be the 4y equals a number. And for this one, just count. And then when we go over vertical, it's going to be in the form of x equals a number. And we simply count again, right? And then we talked about the pre-image goes to the image, right? So this is your original and this is your new. Okay, you guys do have homework on Schoology. Go ahead and get over and start on that.